Now we turn our attention to how to specify a distributed service. To specify a service, we need to specify the interface of the service in terms of what events it accepts and what events it produces. Then we have to specify the property of the interface, which is what sequence of event is allowed by the service. This is the declarative or the what part of a service specification. Given such specification, we left by how to implement it. And this is the procedural or the imperative part. Here we need to state what distributed system model we assume and design a distributed algorithm that satisfies this specification. And that is what we are going to cover now. To specify a service, we have to specify the interface of the service. These are the request events, and to specify the responses. And the responses are what we call indication events. So these are input of a component, input events of a component, and these are output events of a component. Then we have to specify the correctness properties. And to specify the correctness properties, we are going to look to sequences of requests and responses and specify what are the allowed sequences of request and response events. These, as you will see, will be divided into safety and liveness properties. We will talk about this in this lecture. Next, we have to specify what kind of a distributed system model we are working with. And as I just mentioned before, it will be talking about what are the failure assumptions of the model and what are the timing assumptions of the model, which is basically the amount of synchrony that the model allows. So what we have just said now is what we call the declarative specification of a service. The what part of a service, or what we can say a problem. A service and a problem is synonyms here in our case. Now we turn up to how to implement a service. An implementation will be done by saying how we do it, and that is the how part, the procedural part or the imperative part. How we design this service as composed of other services, how we make sure that this component adheres to the interface and satisfies the safety and liveness properties. And while you're doing this and specifying the component, what kind of internal events we are going to have and how they're going to be handled. So as you will see, there will be possible multiple implementations of a service that satisfies the specification. So let us look to a simple service. Actually, this is not concurrent or not distributed, just a very simple sequential service. And this is also describes how we're going to specify things. So service specified by a module, and the module will be the name of the service. In this case, we have a name of that module is the job handler, and we will use this notation GH to denote any instance of that module. We refer to an instance. And then we look to the events. What kind of events? So we are going to have a set of request events and indication event. In this case, for the job handler, there is only one request event, and that is here the name of the request event, and this is the argument of the request event. So the name is submit, and the argument is a job. So a request event in this case, the environment of this component requests a job to be processed. An indication event will be an event when confirmed that the job has been or will be processed. So this event we call it a confirm event, and it will have also an identifier for the job. We use as a convention the instance name to denote what component we are referring to, GH in this case. And here is the property we want to satisfy, which what we call guaranteed response. Guaranteed response says every submitted job is eventually confirmed. So let us look to this again. Here is a component. We draw it here as a box, and this component is a job handler component, JH. It has one request event, which is submit a job, and it has one indication event or output event, which is confirm that the job has been executed or will be executed. So this is the interface. And now we look to the property, which says every submitted job will be eventually confirmed. So how we see this? We can see this as if we have a sequence of events. In this case, we can show it as like a virtual timeline where we place events. And it is saying that this component will accept a submit event, and eventually, so later in this time, if this is job J1, eventually we will get back a confirm event G1. We can submit multiple jobs. Nothing is the specification say has nothing to do with when we submit the job. So we can submit here job G2, and we will get a confirmation. This might be here. Another confirm J2. But in this sequence, the property says if we submit a job, and this is, I draw it like this, then there will be always a corresponding confirm. So this sequence, for every submitted job, there will be a corresponding confirm. It doesn't say when, but it has to have for each submitted job corresponding confirm. So let us see now how we have an implementation of the job handler. And we do first what we call a synchronous implementation. So again, we want to implement a job handler, and our instance is JH. And now we describe exactly what happens when we get a submit event. When we get a submit event, we assume we have this procedure which always succeeds. It takes the job and processes it. And after it processes it, we can now trigger to the environment, to the application, an indication event saying that the job has been confirmed. So first we did a process, and this is, in a sense, a correct implementation because it accepts submit events and triggers confirm events. And as you can see in this execution, for every submit event, we will immediately get a confirm. You submit job J1, we'll get a confirm J1. And then we will accept the next submit, call it sub here, to mean submit, G2, and then we get confirm J2. So this first one is G1. So this sequence satisfies the specification. So the sequence that this implementation produces, or the set of these sequences, are always a subset of all possible sequences that are allowed by this specification. Let us now look to another implementation. This was a synchronous implementation. Let's have a look to an asynchronous implementation. So it's asynchronous job handler. And this is interesting because now we are going to have an implementation of a job handler with a different algorithm. Still satisfy the specification. Still we have an instance G age. And now this component has a state. We will always use the word init to specify an initial event that is generated and executed when the component is created. So init is automatically generated upon component creation, and it is executed before this component can accept any other events. Then we have how to handle a submit event. In this case, we just buffer the job. You see we had first an initial buffer, which is an empty buffer. Here we buffer the job, and we trigger immediately a confirm for that job. So we didn't really process the job yet, but it will be eventually processed. So this is a different execution. And here is a specification that, as we said before, is a specification where we don't specify an event as a message, but only as a state condition. So our state condition here is that the buffer is not empty. So while the buffer is not empty, we select a job from the buffer. This is one of the job in this set of jobs. We process the job and we remove the job from the buffer. So as you can see, this is another implementation. It still have the specification. If you look to the sequence of events happening in the system, a submit, confirm, but the job is not processed immediately. It is processed later, asynchronously. Another possible implementation, which still satisfies the specification, is to delete the confirm triggering here, the output event, and actually do it only after the job is processed. So you have here trigger, again job, here is gp confirm job. So this is another implementation that satisfies the specification, but now you can see that the output could be a sequence of submits followed by a sequence of confirms, which is quite different from the original sequence that is allowed by the formal implementation. We can go further and compose components together. So here is our component that we've just described. So we can think of another component here called transformation handler. A transformation handler accepts a submit event, but it can produce either confirmation that the job has been or eventually will be processed, or it can produce an error. And what the transformation handler does when it gets a submit event, it checks the job first, and it sees if it can be processed or not. If it cannot be processed, it will produce an error event. This is the one that's here. Otherwise, it will trigger the submit event of the job handler. And we know the job handler will eventually produce a confirm. And when this confirm is triggered in the transformation handler, it also trigger upward another confirm. So this is how these composed components together work. We will see many of these during our journey of algorithm in this course.